Hello class, let's continue our lecture video in differential calculus. Now this time our topic is trigonometric functions. Now here are the formulas or patterns that we can use in deriving trigonometric functions. The first one, the derivative of sine u has the answer cosine u derivative of u. So here it is, the answer. Now for the derivative of cosine u, the answer here is negative sine u derivative of u. For the derivative of tangent u, the answer is square of secant u, then derivative of u. For the derivative of cotangent u, the answer is negative cosecant squared u, then derivative of u. For the derivative of secant u, the answer here is secant u tangent u, then derivative of u. For the derivative of cosecant u, the answer here is negative cosecant u, cotangent u, and the derivative of u. Now always remember that the derivative u here is the derivative of the angle u. Okay, let's apply that on the following problems. Number 1, find the derivative of sine 3x. Now sine 3x, for the pattern there is, for the first one here, derivative of sine u. Now here is the pattern. For the derivative of sine u, the answer there is cosine u and the derivative of u. Now from the example, the u there is the angle 3x. So u is the angle 3x and the derivative of u here is 3. Therefore, the derivative of sine 3x becomes, so this is the derivative of sine u, that becomes cosine u, or that is cosine 3x, then the derivative of u, or the derivative of 3x, and that is 3. Now we must remember that the derivative here that we have solved should not be multiplied to the angle alone, rather to the whole of cosine 3x. Therefore, the final answer here is 3 cosine 3x. Now that is for number 1. Now for number 2, find the derivative of x is equal to cosine 4t, or the derivative of cosine 4t. Again, we can find the pattern in solving that here. So we have there derivative of cosine u is equal to negative sine u, then derivative of u. Now the pattern is here. So again, the angle for this du here is 4t. So derivative of u is equal to 4. Therefore, for the derivative of cosine u, the answer is negative sine u, or that is negative sine 4t, then the derivative of u. Again, we will not multiply this on the angle only, but rather in the whole of negative sine 4t. So the answer here is negative 4 sine 4t. Okay, so that is for sample number 2. Next is example number 3. So find the derivative of secant of 1/2 y. So again, we will use the pattern presented above. So we have there derivative of secant u is equal to secant u tangent u, and then derivative of the u. So we have there from the problem, so we have u is equal to 1/2 u. The derivative of this one is 1/2. So that our dx becomes, again, we will copy secant 1/2 y, tangent 1/2 y, and the derivative of 1/2. Again, we will not multiply this on the angles, but rather as a whole. So we have there 1/2 secant 1/2 y, tangent 1/2 y. Okay, so this is the final answer for number 3. Next, example number 4. So find the derivative of cosine t to the 4th power and sine t to the 4th power. This is actually similar to y equals cosine t to the 4th, sine t to the 4th. Now we can use combinations here. So here are the patterns that we can use in solving this sample problem. So we have there this portion here. We can use sine u, derivative of sine u. For this portion, we will be using the derivative of cosine u. And since both have powers here, for exponent, we will use the power rule. So let's apply these 3 patterns. Okay, so the first one, we have there dy is equal to, now the first one we will apply from these 3 is the power formula. So bring down 4. So treat this portion, so looking at the power formula here, treat this portion as the u, and then this is the n. So this is the cosine t, this is the 4. And then later on, what is inside of here, u here, or the cosine t, will be needed for this portion, the derivative of u. Okay, let's apply the pattern. Again, bring down 4, copy u, then we have 4 minus 1, and then the derivative of what is inside, or what is u. That is, derivative of cosine t is negative sine t. Then, we're not done yet. We have minus. How about this portion? Bring down 4. Copy sine t. 4 minus 1. Then, derivative of sine t. Cosine t. Okay? Then, let's simplify. This is actually negative. Negative 4 cosine t raised to 3 sine t minus 4 sine t raised to 3 then cosine t. Or that is negative 4 cosine 3t sine t minus 4 sine 3t cosine t. Now, we can still simplify this portion here because they both have -4, so we can bring out -4. They have cosine and sine. Cosine squared t plus sine squared t. And looking at this portion here, this is actually a one of the identities, the Pythagorean identities. So these are the 3 Pythagorean identities. The first one is sine squared theta plus cosine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. Then 1 plus cotangent squared theta is equal to cosecant squared theta. So if we're looking at this portion, this is similar with the first identity. And the answer for cosine squared theta plus sine squared theta is 1. Therefore, the answer here is -4 cosine t sine t, and that is 1. So the final answer is -4 cosine t sine t. Okay, that is for sample number 4. Now next is sample number 5. So here we have x is equal to 2 cosine squared t over 2. So we will again use the pattern. The derivative of cosine u is negative sine u du, and the power formula. So let's find the derivative. We can write this equation as x is equal to 2 cosine t over 2 squared. So this is similar to the given equation there. So you can see here a power formula. Again, this is u and this is n. So the u here is cosine t over 2 and n is 2. Then we need to derive what is inside, or what is u, and that is cosine t over 2. So we have the pattern. Dx now is equal to 2, bring down 2, and then we have cosine t over 2, 2 minus 1, and the derivative of what is inside. The derivative of cosine is negative sine t over 2, and then if we are deriving cosine u, which is cosine t 2, we rewrite sine u, and don't forget the u. Therefore, this is sine t 2, and don't forget the derivative of the u here, and that is 1/2. So it will take a lot of practice, so you won't forget one step of the solution. So again, we brought down 2 minus 1 there, copy u, then derive what is inside, or deriving u. So this now becomes, now this 1/2 here will not be multiplied again to the angle, but rather to the whole sine t over 2, or the whole negative sine t over 2. So this becomes 4. Let's bring out the negative sign. Okay. 4. Then the 1/2. Then this is cosine t over 2, because we have 2 minus 1 the exponent. Then this is sine t over 2. The final answer na becomes negative 2 cosine t over 2 sine t over 2. So that is the final answer for sample number 5. For problems 6 to 10, it will be discussed in the next video.